In section 8.2, we've got several interest formulas to look at. 4, basically. 1 to calculate just the interest, and then 3 formulas for determining the amount in an account at some future time, or if necessary, if you know the amount at a future time that you need, you can determine what the principal will need to do to accomplish that. Or you can determine, if you know the principal and the amount that you want after a certain number of times, you can determine the rate, annual interest rate, or you can determine how long it's going to have to stay there. In all of these variables represent the same thing. The only thing added here is that in the last one, this is for interest that's compounded multiple times a year, maybe semi-annually, twice a year, or monthly, 12 times a year. Quarterly would be 4 times a year. Daily would be 365 times a year. So let's look at where these formulas come from. If your interest is represented by I, the principal that the account begins with, and for these formulas, this cannot change throughout the whole time period. Your principal is P, your annual interest rate is R, that's always given annually and would generally be given as a percent. And T is the number of years we're talking about. So if you want to know for just 1 year, if you're saying how much interest will an account receive at 6% if the starting principal, and this could be a loan, is $2,000 for 4 years. So just the interest is going to be the principal, that's the $2,000, times the interest rate. Now the interest rate always has to be in decimal form before you can do any kind of math with it. So 6% is the same thing as 0.06. We're talking about 4 years. So 0.24 times 200, 0.06 times 4 is 0.24 times 200 would be $240. Now this also means that if you borrowed $2,000 at 6% for 4 years, and it was a simple interest loan or an add-on interest loan, they call it, that you would have to pay $240 in interest. The future value means how much is going to be in the account after they've put the interest in over that many years, or how much you would owe altogether if you got a loan at simple interest for that many years. Notice that we already determined that the interest was going to be the principal times rate times time. So of course, if you borrow money, you have to pay the principal back. plus you have to pay the interest back, which is principal times rate times time. And what they normally do, rather than having to use the larger number P multiple times, is they factor the P out of this. This is 1 times P plus RT times P. So it's P times 1 plus RT. Now, since the rate doesn't tend to change over time, and the principal that you started with doesn't change over time, if you're wanting to know the amount over a given time, you can actually take the R times T, multiply that out, add the 1, and then multiply that times the principal. For interest, for example, let's go back to the other. If $2,000 is borrowed at 6% interest rate, I guess I should say at a 6% interest rate for 4 years, how much has to be paid back? So you could be on the receiving end of this interest, or you could be on the paying end of this interest. If the amount is going to be 2,000 principal times 1 plus 0.06 times 4, that's going to be 2,000 times 1 plus 0.24. So 2,000 times 1.24 is going to be 22,400. This makes perfectly good sense because in the previous example, we realized that we were going to have to pay $240 interest, and you have to pay both the $240 interest and the $2,000 that you borrowed. Notice here that 1.24 is the same thing as 124%. So if you borrow the money for 4 years at 6% interest, this is the same thing that you would pay if you borrowed it for 1 year at 24% interest. Either way, you're going to have to pay back 124% of what you borrowed. In the compound interest formula, what happens is you start out what happens with the compound interest formula is that you have some kind of an imbalance in the account. So you start out with P in the account. The interest the first year is going to be PRT. So your new balance when T is 1, if T is 1, let's put 1 here for you. Number of years, T would be 1. So we don't need the T in there. It's just P times R. So your new balance at the end of the first year is P plus PR, which we could write as P times 1 plus R. So the second year, your starting balance, because on compound interest, you actually get interest on the interest. So your starting balance for the second year is this, P times 1 plus R. Your interest is your rate, and this is for 1 year, so again, T is going to be just one again. Your interest is your principal. No, your interest, I'm sorry, your interest is your rate times your balance. So your interest now is going to be P times R times 1 plus R. I just threw an extra R in there. The new balance is your starting balance, P times 1 plus R, plus your interest, PR times 1 plus R. Well, this is really complicated, but we could factor out a P, and we could factor out 1 plus R. If we factor P and 1 plus R out of this, that's going to leave a 1 here. And we have factored out everything but the R here, so that leaves just the R. So it's P times 1 plus R times 1 plus R. But this is the same thing as that. So the new balance is actually P times 1 plus R squared. This is the second year. The third time, the new balance that we're starting with at the beginning of the year is P times 1 plus R squared. The interest is that amount times R, because it's going to be for 1 more year. So P times R times 1 plus R squared is the interest. The new balance is the balance that we started with, P times 1 plus R squared, plus the interest, P times R times 1 plus R squared. Again, I can factor out the P, I can factor out the 1 plus R squared, and that's going to leave a 1 from this first term, plus an R from this term. So the new balance is P times 1 plus R cubed. Since the number of years is going to be T, then that means after T years, it becomes P times 1 plus R cubed, hence the formula here. Now, when you use this, you have to be able to raise the 1 plus R, whatever that may be, to any exponent. So you need to make sure you know how to use your calculator to raise anything to any power. And that's actually a different key in different calculators. It might show as x raised to the y or y raised to the x. I have no idea why they choose between one or the other. It might simply show as a caret, the same as the caret that you get when you type a shift 6. And the caret is the notation that we tend to use when we're not able to write something as an exponent, when we're typing something out. So that's where this formula comes from. So if we said, what if we had used the $2,000 at 6% for 4 years when it was compounded. How much of a difference would it make? Well, A would now be 2,000 times 1 plus 0.06 raised to the 4th power. So A is going to be 2,000 times 1.06 raised to the 4th. This is going to give me A equals 2,000 times 1.2624. I'm going to round that to 8. Now, I didn't write down everything that was on my screen, but I'm not going to clear it. So this is going to be the full, I've got 8 digits on my calculator. 5 should surely be enough, because with dollars, we're not going to go out more than 2 decimal places typically. So I get $2,524, and if I round it to 2 decimal places, 95 cents. Notice that this is an increase of $124.95 over not compounding it at all. The only difference with this formula, and you can forget the previous formula and just learn this one. This one is where N is going to represent the number of compounding periods per year. If it's semi-annually, that means every 6 months, N equals 2. If it's quarterly, every quarter of a year, every 3 months, N's going to equal 4. If it's monthly, N's going to equal 12. If it's daily, they usually use N equals 365. And they don't worry about factoring in that extra day every leap year. Let's go with the same numbers and see what would happen if, let's say, it was compounded monthly. We would have A equals 2,000 times 1 plus 0.06 divided by 12 raised to the 12 times 4 exponent. Now, the reason we have to take the rate and divide it by 12 is that we have to figure out how much of that 6% interest they're getting each month, which is going to be 0.5% interest. This is going to be 1 plus 0.005. And we also have to take into account that instead of being compounded 4 times over a 4-year period, if it's once a month, it's going to be compounded 12 times 4 or 48 times by the end of 4 years. So we've got 2,000 times 1.005 raised to the 48. So if you were in hopes that you could just do this by hand and not fool with getting a calculator, I think those hopes have just been put to bed. 1.005 raised to the 48th power. Sorry. is 1.2704. I'm going to round that to a 9. This number multiplied by 2,000 becomes 2540.9. That'll round to a 9.8. How much of an advantage is having it done monthly over having it done yearly? Now, compounding it made a huge difference. If we subtract 25, 24, 95, this is going to be 3 cents, 6, 16. Changing it from annual interest, annual compound interest, to monthly compound interest did not make a huge difference. Another $16.03. I guess every little bit helps. Sometimes they give you both the principal and the amount, and they want you to determine either the time or the rate. We want to look at this one. Sam's going to borrow $400, so that's P. He's going to pay it back by paying $425, so that's A, in 1 month. In 1 month, T will equal 1/12 because it's always in years. If we assume that this is simple interest, then we would say A equals P times 1 plus RT. So 425 equals 400 times 1 plus R times, this would be 1/12 of a year. So this is the same thing as 1 plus 1/12 R. To solve this for R, we can divide both sides by 400 just to get that out of the way. This is going to be 1.0625. That's gone. Equals 1 plus 1/12 R. I subtract the 1 from both sides. I'm going to get 0.0625 equals 1/12 of R. Now, that's actually a fairly decent interest rate for a year, but this is how much 6.25% is being paid for 1 month. If we multiply both sides by 12 to figure out what the interest rate would be if they paid this for a whole year, this is 0.075, which means the interest rate he's being charged is 75%. Sharon wants to deposit money into an account to save for her new daughter's college fund. How much does she need to deposit at a rate of 4.8% to have $60,000 if the interest is compounded quarterly? And this is going to be for T equals 18. So we've got A equals P Now this is going to be compounded quarterly. So it's going to be 1 plus R over N raised to the NT. She wants to have $60,000. We don't know what P is. The interest rate, 4.8%, is going to be 0.048. Make sure you don't put this in as 0.48 because that would be 48%, which would be nice, but it's not going to happen. It's compounded quarterly, so N equals 4. So she'll get 1/4 of that each quarter, and by the end of 18 years, it will have been compounded 4 times 18 times. So we've got 60,000 equals P times 1 plus 0.012 raised to the 72nd. So 60,000 is going to be equaling P times 1.012 raised to the 72nd. This comes out to 2.36046. If I divide both sides by 2.36046, I'm going to end up with P equals 25,418.77. $25,418.77 will grow to $60,000 in 18 years. Depending on how far you carry out your decimal points, you may be plus or minus a penny from this, but it shouldn't be very far off.